Hi everyone, I'm Darshan Senthil, and in this video I'm going to be talking to you about quadratics yet again. So this is going to be my fourth video in the series of quadratics, and we shall be talking about two things in this video again. We're going to be talking about intercept form and factoring. So let's just get started. So again, I'm just teaching you these two concepts so that you can understand, because they tie in together they tie in together well, and they're sort of related to one another. So again, I just like teaching them together. You may not see this way in textbooks or in your typical algebra 2 or pre-calculus class, but I just enjoy teaching it this way because they're really related. And if you know one, then the other sort of comes naturally. Okay. So now in intercept form, all this is another way to write a quadratic or a quadratic equation. I'm just going to write quad equation. So you've seen y is equal to ax squared plus bx plus c, which is standard form. You've seen y is equal to ax minus h squared plus k, which is vertex form. And now this is just intercept form. And intercept form is represented as y is equal to, let me do that in a different color. Actually, no, I'm just going to stick to yellow. Y is equal to a x minus p x minus q. Let me outline that in red. So this is our equation for intercept form. And actually this is the same thing. And one thing I should tell you is that all these different forms, in the end, like whether this one or this one, in the end they all tie back to this guy here. So if you actually FOIL this out, like if you multiplied x minus h squared, if you wrote that out, multiplied by a and then added k, you would get this thing over here. If you multiplied all these, again you would get this thing over here. Of course, in this case you would not get the exact same thing because you've got variables, but if you had numbers in here, then you would eventually end up with this thing right there. Okay, so all of these are just basically different ways of writing it. Just like you spell the word gray differently in British English and in American English. These are just different ways to write this one equation. Okay, they represent the same thing, and sometimes it's more useful to have this form than that form, and they tell you different things in a more easier way. Okay, so yeah, that's a basic overview of intercept form. And now let's just go into a little bit more in depth onto what exactly it shows us. So I'm just going to draw a little graph over here. So to show you exactly what intercept form tells you. So intercept form can tell you two big things. So the first thing that intercept form tells you is that it tells you, as you might have guessed, intercepts. So it tells you your intercepts, and your intercepts are represented by the points 0, p, 0 and q, 0. So if you actually took this kind of a quadratic and you graphed it, you'd get that these 2 points here are p, 0 and q, 0. Okay, so those two would be your intercepts right there. And this is useful when you're solving equations, and since you often solve to find zeros, as you've seen in previous examples, which is why I think this video will be particularly helpful for you when you're dealing with quadratics. Okay, and another thing this tells you is it tells you your axis of symmetry. Okay, so you may ask how that tells you the axis of symmetry. And firstly, I want you to think about this. What do these x values represent. So you've got no y value here, so your vertical component is out of this. So but you've got two horizontal movement components, or two x coordinates. So basically what that tells you is it tells you your distance from the y-axis, right? Each of these this p and q value, all they're telling you is your distance from the y-axis. Okay, so they are a kind of absolute value distance. So for example, this could be 5 and this could be -5, or if things were a little bit more complicating, that could be -3 and that could be 6. So either way, what they're telling you is that they're telling you the distance from the y-axis. But however, we know that quadratics, they have the property of being symmetric. So as you may have guessed already. So if you wanted to find their axis of symmetry, all you need to do is find the mean of these two distances. Because they are telling you 2 points on the x-axis, and if you looked right between them, exactly at the same distance from each of them, you would find your axis of symmetry. Okay, so I'm just going to write that out here. You find the average, or the mean, of two average of intercepts. Okay, so I hope I didn't confuse you too much over there, but basically you're just going to find the average of your two intercepts, and that will be where your line is. Now usually with the y-axis you'll have something like -3, -0 and 3, 0, and that would be, and if you had that, then you would just simply add the two of them and you'd get 0, 0 as your you get 0 as your mean. So hence your axis of symmetry would be x is equal to 0. But what if you had something like -6 and 5? Wait, no, that's not right. It's -6, 0 and 5, 0. What if you had something like this? Then you would need to actually add and solve. So this, if you have the same thing like this, the same absolute value distance, then it's usually across the y-axis, or the line x, 0, x is equal to 0. But if you had like different things like this, then you'd actually need to add and solve. So this would be -1/2, I think. X is equal to -1/2. So you can verify this if you want. And that's basically how to solve this. So one more thing I want to talk to you about in this video is, wait, let me just get rid of all that. Just want some more space here, so I'm not going to erase like everything, but just a little bit. It just came in well. Okay, so the next thing I want to talk to you about is factoring. So factoring is like these two are other ways to, like what I did when I taught you these two forms. I also taught you two ways you could solve equations like this. So with each form I taught you a way you can solve the equation that comes well with this form. So when I taught you standard form, I taught you the quadratic formula, because you've got the components that are needed for quadratic formula in standard form. When I taught you vertex form, I taught you completing the square, because completing the square is basically putting something in vertex form. And now I'm going to teach you factoring. So factoring basically puts your thing in intercept form. It puts your equation in intercept form, okay? So let me just walk you through factoring. So for example, say you had something like this. Say you had a number like 32. How would you write this as two factors? You would write this as 16 and 2 maybe, or you could write this as 8 and 4. Who knows? Either way, you'd write this as a product of two factors like this. And then you could split this further into 8 and 2, and that into 2 and 4, and so on and so forth. So that is basically the same thing you do with factoring. So let's say you had something like this. How would you factor this? You would pull out a 2. You'd see that both of these have 2 in common. So you'd pull the 2 out and write x minus 1. That's how you would factor that. Okay. So now let me but what if you had something like this? X squared minus 4x minus 3. How would you factor something like this? It looks a little more complicating, right? So let me just walk you through some examples here to show you how you could factor something like that. So in this first example here, we have what looks like a pretty big quadratic here, like 105. These are really big numbers. But now I'm just going to show you the first thing you need to look for when you're solving quadratics, and that is look for a GCF. Okay, always look for a GCF. Okay, so if you see that because if you find a GCF, it saves you a lot of simplifying at the end, and also makes the quadratic just that much easier to solve, because when you have smaller numbers, things often look a little bit nicer, and you're less likely to make mistakes that you get from like having big numbers. So what GCF do you see in all of this? Well, I see 3, so we're going to pull a 3 out, and we're going to rewrite this as x squared minus 16x, if you divide that by 3, plus what's 105 by 3? It's 35, equals negative 25. Okay, so that's that. Now the next thing you want to do is you want to set your equation to 0. You want to set your equation to be equal to 0, and that's just because it's a little bit easier to solve when you've got 0 on this side, because that means that what you do on this side does not necessarily need to affect what you're doing here. So for example, if you wanted to like pull a common factor of 4 out of this side, you would not need to worry about the 0 on that side, and hence it just sort of saves you a little bit of time, I guess, and makes you a little bit less likely to make mistakes. So we're going to add 25 to both sides of this equation. So I'm just going to do that in red. It's 25 and plus 25. So if we did that, we'd end up with 3 x squared minus 16x plus 60 is equal to 0. So now we're going to, now here it looks a little bit like we can't factor this, but if you actually but remember what we did with the example in the previous slide, like we did when we had x, like 2x minus 2, we split this up into 2 and x minus 1, right? That's because it's easy to split up linear factors like this, kind of. So it's easier to do it when we've got groups of 2, terms, because then we can split up we can find a common factor and pull it out a lot easier, right? So you with me with this? So we're gonna try and split this into sets of 2 terms that have the same factor, because if you look at this, if you've got 3 terms here, then that makes your chance of finding a common factor 3 times harder. But if you've got 2 terms, that makes it a little bit easier. So we're going to try and split this into 2 terms. Okay, so that's our third step. Split into sets of 2. Okay, so we're going to split this into sets of 2 terms. So I'm just going to ignore the 3 for now. So when we split now, we're just going to do a little bit of we're just going to try to split to make it a little bit easier. So we're going to find a number that we're going to split this middle term here. Okay, so we're going to split that into a number that now if we wanted to make it something like this, we'd want something that works well with this 60 over here. So we want to split it into something that, into 2 factors that would multiply to give us 60. Okay, so yeah, I hope you got me. So we want to split this middle term here into two terms that equal our 60 here. So into two terms, third that multiply to equal third. Multiply to give third. That's just because it makes this, it gives you a more common factor. It gives you a common factor that you can work with here. So we can split 16 into what two factors to give us 60? Well, we can split it into -6 and -10. Now again here, I just want to make a point that you should pay attention to your signs. Always pay attention to your signs, because sometimes you may have a factor that actually works with negative and positive, and something that doesn't work because you have two negatives or something like that. So just pay attention to your factors. Oh, and I should probably erase this so that it doesn't cause any more confusion. There we go. So we're going to split this into -6 and -10. So this will turn out into x minus 6x minus 10x. It doesn't really matter which order you have these in. And I hope you notice that we're not really changing anything in this equation, right? This is the same thing as writing 35 as 10 and 25. We're not actually changing the equation, we're just manipulating it slightly to suit our purposes better. So we're not actually changing the value of the equation. Just keep that in mind. So now we've grouped this into two separate terms, into two separate sets of two. So we've got this and this. We've grouped into two separate terms. So now we can just factor each one individually. So I hope you see what we've done here. We've split this into two separate terms that we can work with individually. So this will be x times, if we can pull out an x out of these two terms. So we're going to put x, and what we have left? X minus 6. And then we have the negative, and then what goes into 10? What is the common factor between these two? Well, it's 10. So minus 10, and -10 goes into 10x, -10x, x times. And make sure you pay attention to the sign here again, because the negative times, oopsies. Because the -10 times, because it takes a -10 times a -6 to give you positive 60. So just keep that in mind. Again, just pay attention to your signs. So this would be x minus 6 as well. And now if you notice here, we've got two things. And now we have a new GCF here in this equation, and that is x minus 6 is our new GCF. So we're going to pull that out of each of our terms, and we're going to write this as x minus 6, x minus 10. And we shouldn't forget our 3. So we're going to pull that guy down here as well. That'll be 3 is going to be equal to 0. Okay? So this would be your final answer if you're asked to factor it. Now if you're asked to solve it, you need to, oh wait, I forgot to write the step here. Factor. So now we're going to solve these. If we were asked to solve these, we're going to use something called zero product property. Solve with zero product property. We're going to use something called zero product property to solve this. Now let me just explain that to you in a second here. So we've got 0 as our answer to this. So is 0 divisible by anything? Like, are there any two real numbers that would give us 0? No. If we wanted 0 as our product, we'd have to have a 0 in here. Am I right? So in order to get 0, one of these must be 0. Must be 0. One of these terms here must be equal to 0. You can't have 3 is equal to 0. That's not right. So one of these two binomials here must be equal to 0. So what we're going to do now is we're going to set each one of them equal to 0 and solve. So, okay, whatever. X minus 6 is going to be equal to 0. If x minus 6 is equal to 0, then x would be 6. And what if x minus 10 was equal to 0? X minus 10 was equal to 0, then x is equal to 10. Okay? So now our two solutions to this equation would be 6 and 10. We put these in these sort of squiggly brackets here because it's not a coordinate, and this would be your final answer. Okay, that's how you would solve. You just solved using factoring, so that's how you would do it. Okay.